Sunil, are we good? Okay, we are back live for the second panel session, and we do have everyone on seat. Great. This panel session will be on efficiency and reduction of embodied emissions in building materials investment in technology and research, and we have a great list of panelists here. I would like to introduce our moderator, and that's the person of Kirils. Kirils is the co-lead of WFEO, Young Engineers, our Future Leaders Working Group on Climate Action. He will be introducing himself much more, and then we'll get on started with his panel. Thank you all.
Thank you very much, and welcome everyone. So Kirils, Holstovs, I'm an engineer at ACOM, and also co-lead the Young Engineers Future Leaders Working Group on Climate Action as part of WFEO, which represents 30 million engineers in 100 countries globally. So it is my pleasure to chair the session today on this very important topic. And we know that buildings account for about 40% of global emissions, which includes both energy demand and use of materials. If we consider the materials themselves, such widely used materials such as steel and concrete account for about 14% of global emissions. So we know that as an industry, we have a huge challenge. And still, so many buildings are yet to be built, as in developing countries, we seek to address the housing issues and improve the quality of living, and also in advanced economies, as we seek to balance demand and supply. So I think we're going to have a very engaging session today. So thank you very much for coming, and also welcome to our online audience. And we'll start with the introductions. So it is my pleasure to introduce firstly Emmanuel Normand, who is the Vice President of Sustainable Development of Saint-Gobain. Emmanuel is an engineer. Before joining Saint-Gobain, he worked for the French Ministry in charge of environment with various responsibilities. And eventually, he worked as a technical advisor to the ministry. Emmanuel is also the vice chair of the World GBC's Corporate Advisory Board. Since 2002, he has worked for Saint-Gobain, mostly within the construction product sector in Brazil between 2002 and 2005, in China between 2005 and 2012, and in France since then. In Asia, after having been in charge of the development of the pipelines activity for China, he took over the responsibility for General Delegate for Asia Pacific for the Saint-Gobain Group, as well as Regional Managing Director for the construction product sector for the same region. So, a very warm welcome. Next, we have Adrian. Adrian Gachpo is the president of the Chartered Institution of Building Services Engineers. He is also the chairman of John Slater and Howard Consulting Engineers, where he is a strategic lead for business development, digital engineering, and carbon reduction. He has almost 40 years of experience in the industry, in a wide range of projects from local authority heating and rewiring contracts to 70 million plus commercial developments. He is also a keen promoter of collaborative working throughout policy, design, and construction teams as a means of delivering buildings that work efficiently and effectively from inception to end of life. Welcome. Next we have Uzoma. Uzoma Anugom is the Chief Operating Officer of RDC Property Group, based in Botswana. He is an experienced real estate professional with experience in property development management, property finance, and investment analysis, asset management, property management, facility management, and other fields. And he works on a wide spread of real estate sectors, ranging from corporate to commercial to residential developments and investments. And he also has significant exposure to publicly listed and private companies. Welcome. Dr. Christine Lemaitre is the Chief Executive Officer of German Sustainable Building Council, which is the biggest green building council in Europe. And she works on advancing member certification and training since she has assumed the role as a CEO in 2010. And the German Sustainable Building Council has developed and maintained the most advanced certification system for buildings and city districts. Christine is also responsible for developing the international activities of the German Sustainable Building Council and has developed and fostered very successful collaborations with the like-minded green building councils in Denmark, Austria, Switzerland, and Bulgaria. Welcome. And next we have Dr. Stefan Buttner, who is the chair of the UN Economic Commission for Europe of experts on energy efficiency. So Stefan is the director of global strategy and impact at the Institute of Energy Efficiency in Production and chairs the UN ECE task force on industrial energy efficiency, as well as group of experts on energy efficiency. As initiator of Energy Efficiency Barometer of Industry and former project lead for the Energy Efficiency Index of German industry, he also facilitates demand-side informed energy efficiency actions. And last but by far not least, Craig Thackeray, the Vice President of Environment at AECOM. So Craig is responsible for the environment business line within the Middle East and Africa at AECOM. He's also extensively engaged in regional civil and infrastructure projects, particularly in the transport sector. He's a chartered engineer, he's a chartered environmentalist, and a chartered manager, as well as a fellow of both the Institution of Civil Engineers and the Chartered Management Institute. And AECOM are very engaged in several high-profile projects as sustainability consultants using innovative digital tools to determine both embodied and operational carbon of proposed assets that inform the design process. And he leads the regional Sustainable Legacies program, and especially the Scope X, being the AECOM's approach to reducing the carbon on all projects. So thank you so much, everyone, for joining this panel today. We have a very broad list of topics to cover because the building materials is such an incredibly important area to decarbonization. So firstly, I'd like to start with a question: what innovative technologies and materials have shown the greatest potential for reducing embodied carbon emissions in construction industry? And also, even more importantly, how can they be effectively integrated into building projects? So, Adrian, how about to start with you?
Thank you very much. So as far as emerging technologies, there are emerging technologies. We think about phase-change materials is an obvious one. But I want to draw attention to the fact that the biggest impact on embodied carbon is actually to reduce it before you get to the innovative technologies. And that's one of the things that we're trying to bring attention to. So we've now got, more so than ever before in the built environment, we've got digital tools. We can do climate-based modelling. We can define our building. We can run different simulations on it. We can look into the future, not just designing buildings for now, but in 20, 40, 80 years' time. So we can look at the effects of climate change on the buildings. So first off, in terms of integrating the buildings, is to use a fabric-first approach to drive the demand of the building down, and then you look at different technologies. And the technologies are largely the usual ones. The PV, they're using passive systems, looking at daylighting, orientation, and things like that. But we need to make use of those in a much better way, and to look at. So once we've done all of that, we can then look at the embodied carbon, and there's various tools for doing that. SIBSI is championing its TM65, of which we're now rolling out across the world. So we've got local carbon factors to be able to do that accurately. Still putting the pressure on the manufacturers to do their EPDs, because that's ultimately on a component by component basis. But in the meantime, we have got other tools. Sibsy's tool obviously focuses on the mechanical and the electrical services equipment, but it aligns to other methodologies like the RICS, the Royal Institute of Chartered Engineers. So they're doing the building stuff. So really, it's driving that. We know what the potential is. We know. I think you alluded to that. 30% of the whole life carbon is what we specify and how we do it. So that's an area that we are trying to bring attention to everyone to look at, because there's some big wins there, low hanging fruit that we can do. All right.
Thank you very much for this remark. And Emmanuel, based on your vast international experience as well as advising the ministry, what technologies and approaches in reducing embodied emissions of materials are you most interested in and most hopeful for?
Oh, thank you. I want to say good news. We are not talking about emerging technologies. There's a lot of existing technologies that allows already to reduce by more than 2/3 the carbon content of buildings, looking at the whole life cycle of buildings. I want to mention, beyond what we are doing in terms of energy efficiency, I want to mention two ideas. As we know, most of the embodied carbon is coming from heavy built materials, being concrete in particular. So the question is, can you remove concrete? You mentioned already an idea. I gave you a second one, which is to replace, whenever possible, concrete by so-called lightweight materials, being frames made of steel, wood, aluminium, plasterboard, insulation, and wherever you don't need concrete because it's not structural, you can replace it by this type of solution. And then wherever you keep concrete, there are more and more solutions to be able to reduce the carbon content of the concrete. And we are developing what we call construction chemicals that allows to significantly reduce the amount of clinker that you are using in the cement that is going into the concrete in order to reduce the embodied carbon of the concrete. And finally, and that maybe I can talk afterwards, more and more, those solutions that we are developing will be fully decarbonized.
And Stefan, what is the role of alternative materials? Or do we have to keep working on the most popular materials to decarbonize them? Would really welcome your opinion.
Thank you. Well, as you already indicated, there are lots of avenues that we can use and pursue and that exist, but we need to look across the board. And there are a few things that you already aimed at, and I would like to go a bit deeper on those. That could be, for example, textile, concrete, where you, instead of steel, use also fibers that are stronger even and last twice or three times as long. Things that are rather creative, such as pullovers, like jumpers for buildings, to retrofit them, particularly industrial and commercial buildings with odd shapes, using artificial intelligence and 3D imaging to tailor that at cheap cost. And of course also something that we have known in the past, and that is rediscovering materials that mankind has been applying for thousands of years and that we abandoned with the concrete and steel age, and of course passive design mechanisms. So that's just for the materials, and of course identifying where we have the most emission intensive steps in the manufacturing of those processes, and for instance the clinker process, and harness waste heat and all the waste energy sources, or avoid them in the first place.
And Azuma, thinking about the perspective of developing countries, how do we follow those innovative technologies, and how do we reduce the carbon impact of building materials, for example, based on experience in Botswana?
Okay. I think it's a good thing you mentioned from a developing nation perspective. The key thing here is you look at the building life cycle process. The most important component of that process is the design. And in the design stage, that's where you can actually set the tone for embodied carbon emission reduction. And practically, I mean, it's a good thing that I think it was last year or thereabout, IFC launched the EDGE, which most of us in the developing nations now we use. So what it helps the entities in Botswana that want to toe the not just in Botswana, in Africa, that want to toe the green sustainability design thing would be more like helping them move away a little bit from material specification design to performance-related decisions. And when you're looking at those performance-related decisions, that's where the EDGE becomes a very important tool. It helps you look at the building morphology. It helps you deal with the issues of specifying the right materials for the substructure component of the building, superstructure, and the building facades. Those are the three major components. I think if you're thinking of embodied carbon emissions, those would be in the range of, say, 12 to 21% of the total emissions. So if you can deal with the concrete, steel components, and those occur mainly in the foundation stage, then the superstructures and the type of cladding you give to the building. So we tend to approach it more from a design perspective, and we tend to get all the respective professionals aligned and help them see the end results. That's why in developing nations, we lay very strong emphasis in getting a very competent development manager to drive the process. He should be one that is attuned with hitting the 2030 1.5 degrees Celsius target. And if he's not in line with that, then he's not the right person to drive your project. So that's the way we approach it. Thank you.
Thank you. So we have talked about how we can approach this, but what actual successful case studies have we seen? So Craig, with ACOM being at the forefront as a designer and consultant, what can you share with us in terms of ACOM's decarbonization practices, and what successful projects has ACOM had?
Thank you, Kirils. I think very much to Adrian and Emmanuel's point initially, I mean, technology and innovation are enablers in this field. So giving specific examples as well, we go back to the design. So some examples, and since we're in the Saudi Green Building Forum, I'll give you a couple of examples from Saudi Arabia. As infrastructure designers, we've got tools like, for instance, Eco0, where we actually look at concept design stage, what the embodied carbon and the operational carbon is of a structure that we're going to design. And then pretty much we can actually enhance during the design, and we design based on the outputs of that. So an example that we have is we had a massively long utility corridor where the conventional design is box culverts. But instead of actually doing the box culverts, our team innovated, and they came up with a double arch to take the same loadings, and obviously there was the buildings built on top of it. So again, by doing just that, in terms of embodied carbon, we saved 22%. In terms of efficiency, the construction process was 1.5 to 2 times quicker, depending on which part. And also, I think the best thing for the client is it was a 15% cost saving, which comes back to reduction again. So I'll give you another quick example in terms of something that we've done. You know, using the tools is very important. So again, we were looking at buildings. So we invested in actually getting the soil conditions into the packages, into the tools, and looking at the costs as well, because that's a fundamental driver for everything that the clients do. So again, we then looked at how many piles we needed, what the building foundations were, and again, looking at not just the embodied carbon within the materials, and then we also looked at, you know, how we looking operational, how do we reduce that? But I think fundamentally our outcome for this was very successful in both instances, saving time, and That's why carbon does pay. You know, carbon reduction, we've proved it, the economics of it. So it's something that's very, very important that, you know, it doesn't cost more. And if you integrate sustainability and decarbonization within your designs, again, you'll achieve a better win-win outcome for all responsible. So again, it's very important. Some examples that I've given, I can't talk too much specifically about them for NDA purposes, but there's a couple of really good examples out there that we've seen the benefit of.
And Christine, as the green building councils across Europe collaborate, what can we learn from Germany? Like, what can we learn from Europe that everyone should be aware of? Thank you.
Yes, thank you. Maybe you can learn what you should not repeat to do. So I think in Europe we learned our lessons. We've seen that this one fits all in approaches to technology doesn't work, and that we now have a challenge that basically we designed buildings for a climate that is not there anymore. So I think we have to be as well very honest looking into the future, and we're now having in Europe very much an overheating problem in our cities and our buildings. Already 2/3 of German office buildings, modern office buildings, are artificially cooled even in the winter. They have too much glass percentage. So I think what we need, maybe coming as well back, I think one thing is the realization that we have an embodied carbon challenge as well in the built environment. But I always like to quote Cedric Price. He was an architect from the UK, and he said, once technology is the answer, what was the question? So I think we really have to go back and really think about what makes sense in that region, at that location, in that culture. And we have to maybe have a higher self-esteem when it comes to our built environment, because that old architectural model we've seen, and we see here as well in Dubai, has failed. And it's not that we didn't know it better, but I think we have to learn from the past, and I think we have to look into the future. And we are designing for a world that is warmer, a world where you have more people living in the city. So we have to focus as well very much more on what happens in between the buildings in a city. I try to walk around Dubai on Sunday. That is quite a challenge if you don't stay on the normal roads. So I think we have to come back to a certain honesty, decency as well, maybe sufficiency. Like, how much material do we really need? How much building do we really need? Can we keep existing buildings? This is, from the European perspective, is like the first step. It's like, can we remodel the existing building? That is so much embodied carbon saved if we just work with the existing building stock instead of demolishing. I think we have to be honest. Every construction has emissions. So if we build, and I think that is maybe something as well for the regions in the world where a lot of construction will happen, it has to be good invested CO2 emissions. So we have to go back to the mindset that we built for 100 and 200 years. And then we have to be very critical on how much technology do we use for that, because technical equipment in a building maybe lasts 20 years. So we have that kind of disconnect. So I think that is maybe something I would like to share, because that is a big trend we see at the moment in Europe, is going back to low tech. No air conditioning, more massive buildings, because we have this overheating challenge, where we already see that these wood frame buildings will have a challenge because there's no mass. In order to that, we should maybe go back to an architecture how we used to have it in the 1800s with higher ceilings, because that makes the comfort in the building much better. The air is kind of then getting lazy, so you don't have this overheating and quick cooling challenge. So I would say low tech is actually something where we go back. And maybe one last point, when we talk about embodied carbon and life cycle assessment, mostly we don't talk at the moment about the transport emissions, of how much emissions do we have to move material from A to B. So I think it's as well a very regional question of what kind of material to use. And I think we really have to look at it in a regional context, because I just heard about a competition for a high-rise building in Hong Kong that's supposed to be out of wood, and the wood is supposed to come from Austria. So we don't even have to do an LCA to maybe realize that there's something wrong. So I think this regional part is a very crucial part when we build in the world, and how we treat our existing building stock.
It is such an important point on how we changed our thinking. So not only resorting to those alternative technologies, but also how we actually approach building design, and also how we maximize the use of existing assets to actually remove and reuse that embodied carbon. But so next, Emmanuel. So on the use of alternative materials and sustainable materials, so based on your international experience, as well as experience in France, I'd like to know, what is the availability of those technologies? How easy is it to get access to them? Does supply match the demand?
Globally speaking, I can only talk about Saint-Gobain. The materials that we produce are being produced locally, and most of the resources that are being used are available locally. What is not yet available locally is decarbonized options for those materials. If I take glass, for example, and we can have very efficient glass also against heat, we can also have decarbonized glass. And I don't know how to produce glass without energy, but I know how to produce glass without carbon. And actually, we're multiplying the experiences at industrial scale that, yes, we will be able to produce glass without carbon, glass which will have a very high level of recycled content whenever the recycled content is available. Glass that can be produced with a very high share of electricity, and the remaining gas being either biogas or clean hydrogen. And we're making the demonstration that it's technically feasible. We have already launched across Europe a range of product of glass, which is with 70% of recycled glass, which has 40% of reduced embodied carbon. But there's a challenge. Yes, there's a challenge, which is, in that case, not so much the availability of the raw materials, but the availability of recycled content, the availability of clean energy, affordable clean energy, and that's today the challenge that we face in order to be able to roll out in different geographies the solutions that we are developing.
Thank you, Emmanuel. And also, I'd like just to encourage our panelists to engage in discussion and also comment on each other's remarks as well, because we want to have kind of the dialogue. Adrian, research and development, what role does it have to play in this hugely important transition and to reduce embodied carbon of materials?
Yeah, well, at the risk of repeating myself, I think all of these discussions, listening to you, on the building materials, there's a lot of research and development going on. You know, I was at Harriet Watt yesterday, and they're recycling, or they're using recycled bricks to produce with 95% less embodied carbon. You know, concrete, cement, there's you know, even timber. There's a lot of work and research being done that. But then you get to the M&E equipment, and it's predominantly constructed of metal and plastic, and whether it's that they're complex, expensive things to do, because fundamentally what it is they're doing, they're made out of those products. So we need, there are initiatives, you know, zero steel, for example. You know, we've got to pursue those, and whether that's industry needs to look at that, because that's definitely a barrier to progression on looking at reducing the embodied carbon in building services equipment. I mean, there are, which is why I said what I said about reducing it. I mean, it's the old adage of, you know, there's no better way of saving embodied carbon, but to use less, you know. So, listening to your point about the projects and the case studies, and similarly the research that Sibsy's doing is looking at even component by component. You take something like even a heat pump or a chiller. you know, if you do your modelling correctly and you can drive the demands down, you can and you look at it over a period of time, then you can. You're absolutely right. You can reduce the embodied carbon of equipment by 50%. You know, just by sizing it at the optimum levels. Now, of course, there's a flip side of that we need to think about, which is the other message we're trying to get across, is that, and you alluded to it, we do need to face up to the fact that the climate is changing, the temperature is going up, and the buildings we're designing now may not work in 40 years' time, 60 years' time, 80 years' time. So we have to. So we're looking at projects I'm working on in my practice. We're doing those analyses. We're looking 40 and 60 years into the future. Get the point that the mechanical electrical systems will change in that time. So and that science and technology will move on and the equipment will get. But there's still the impact of that. But so we're looking at where we can naturally ventilate a building now. That's fine for the occupants, but in 20 years' time, the temperature will have gone up, and certainly 40 years' time, we'll need air conditioning. So what we're in some of the designs we're doing at the moment, you look at it, you can put in the infrastructure now, knowing that it's going to come. So then you're not doing abortive work. You're building and you're designing, which was your point. You're designing it now, but for the duration. And as you say, we need to get back to designing buildings for 100 years, 150 years, and to do that, we need to be thinking about that at the design stage, which is your point.
Of course, Christine.
Yeah, sorry, but to build to that or to add on that, and I think because we're in the year 2023, so the COP15 has been a few years ago. So I think we really have to as well switch into being more pragmatic, and we have to look at where the low-hanging fruits. And I think one thing is, when we talk about buildings, I think we have to be as well very honest about, what kind of comfort zone are we building? I mean, just saying that because I'm sitting here in the airflow of the air conditioning, I'm the only one with a t-shirt on, so to me it's a bit cold. But this is kind of, to me, is always very bizarre because we build these buildings and then we have an indoor comfort, which is maybe just comfortable to some of us who are wearing a suit and a jacket on top, but for others. So that would be very easy to kind of go out of that wannabe comfort zone, a few degrees up, a few degrees down. And we're actually having a conversation around health, at the moment with doctors. And they always say, this is actually the wrong thing to do because a healthy human person needs to get out of the comfort zone. This is when we do sports, that takes us out of the comfort zone. So it's actually not healthy that we sit in artificial environments all day long, or like we see here, like walkways, then we go into the mall. So I think we as well have to rethink and get more common sense back into our built environment. And it's not that we cannot take certain temperatures. Humans adapt very quickly to temperatures. Like in Germany, we have the effect in the spring, 15 degrees, everyone is running around in shorts. In the fall, 15 degrees, they're already on with their winter coats because you just need a few weeks to really adjust to a temperature and a climate. And I think there we can maybe come back to more common sense and more really understanding of, and we don't need to have these fully automated buildings. I mean, we can open a window, we can do things. This is I think, and this is what really worries me because we're kind of building buildings, they're not even healthy for us. So I think we're the only sector who can bring together healthy and well-built environment with drastically reducing emissions because we're still in the world of unnecessary emissions. We're not talking about taking something away, we're talking about better design, and that will drastically reduce emissions at the same time. So I don't know why we're always so afraid of that change, because change can only be in the positive direction when you look into our cities. They're too hot, they're too dirty as they are today. So we can't just improve them, so we should get going. And I think that is maybe something I wanted to bring in the discussion.
Yeah, no worries. To add on that, now I'm really scared of flying home when it's snowy at the moment. But if we succeed in enabling all stakeholders, that means among those who design buildings, among those who design the products for buildings, among those who are using buildings, to identify what wasted resources are, and we cut on that waste, then we proceed quite a bit, and we empower and enable stakeholders to see where further improvement opportunities are.
And so I think one thing that we can take away from this as well is that climate change effects are getting more and more adverse every day. So we have to make sure that our buildings are fit for purpose. So not only avoiding the unnecessary emissions, but also preparing for the increasingly adverse climate effects. And Uzuma, from the African perspective and developing country perspective, how do we do that? How do we ensure that our buildings, which require significant growth and construction over the coming years to accommodate for the demand and accommodate for those increasing well-being? How do we ensure that buildings are fit for purpose for the decades to come as weather conditions get worse and worse?
I'm just going to give you an example. Like yesterday, I just got a message on my phone from Meteorological Department Services notifying us about the heat wave issues. Yesterday, we were warned that between now and the 6th or 7th will be anything between 39 to 41 degrees Celsius. And that's bad. You can literally get an egg to boil outside 41 degrees. So it still piggybacks to the design process. And now it's more, I'll approach it more from a collaborative perspective where all the designers, the design function plays a very important role here, and R&D also helps. Practically what we're going to be looking at here would be what type of building systems, what type of construction methods are we going to be deploying? And the contractors here are very important stakeholders because they've been exposed to very many equipment in the industry. And you find a builder as well, there's some type of construction materials that say the architect will propose. He will clearly tell you what not to use based on his experience from previous construction projects he's actually done. So thinking about it, all we're doing is, the most important thing is how do we deal with the building envelope to make sure we keep the cooling inside at different weather season, and to keep the heating as well, different weather season, without demanding a lot of cooling load, a lot of energy. Because here, when we are able to save on the materials, specify the right materials based on the performance, then we are able to save not just on the embodied energy perspective, on the operational carbon emission perspective, because that's the long term that drills the hole in our pockets. We are making a proper shift from the usual R410 HVAC cooling systems to now I think is the R32 or thereabout. But that's mainly for the cooling. How do we employ more natural cooling systems, green systems in the buildings, in the developing nations? These days we're doing a lot of things from, in fact, implementing the cavity walls, having to insulate the walls from the external wall perspective, dealing with the wall-window ratio, re-specifying the type of slabs that we keep, roofing insulation systems, type of roofing that we keep in the houses, the different types of lighting systems, and even we're now pushing back not to be getting the T5 fluorescent systems into the system anymore. All the specifications are going straight to LEDs. And while we're doing that, most of the suppliers now, we also look, from a listed company perspective, we also look at their ESG drive while we're also engaging with them. And when you are not working towards aligning with the 1.5 degrees initiative, it becomes a problem. Because if we get them to understand that I'll buy from you if you're working towards that, they look for more sustainable products to pitch to us to buy. And that's one way to get them to align. They start thinking, and they start bringing in products that will actually help us. So it's all a kind of system. Everything works in a concerted effort, from the designers to the equipment installers to the ones deploying to the ones you procure from. It's all a systematic process. So stakeholder engagement here is very important, and the awareness driving down the goal you intend to achieve, and not just hitting a nail on the bottom line, which, I mean, obviously is important to us, but it's not just a key thing to achieve, but getting a very efficient building that helps us run long term is one of the major goals we try to achieve.
So Uzuma mentioned the concentrated effort from a wide range of stakeholders. And Craig, as we see, so in this incredibly important transition, we need to understand what are the barriers and challenges, and also what strategies we can employ in order to address those. So can you comment based on your experience?
Yes, I think as Uzoma said, I think collaboration is a very key aspect to this. So I'm going to bring it into the region here. So the Ministry for Climate Change and Environment here is very engaged in that collaboration process. They've also approached companies like AECOM and signed a sustainable, responsible companies pledge. So again, we're helping to actually move this quicker, because decarbonization, there's a lot of talk and no real action. So in order for us to decarbonize the buildings, we've got a lot of buildings that have been constructed in the not too distant past, the last 10, 15 years. So I'm aware of for instance, DEWA, the Department of Electricity and Water in Dubai, based on a workshop that Her Excellency the Minister ran in May, Miriam Al-Hajres. They've pretty much committed to retrofit 30,000 buildings, spending billions of dollars to do so, because they realize we've actually got to do that to meet our 2030 targets. And I think what everybody fails to understand is there's a ticker going here. You know, we're running out of time. You know, we can see the climate change is becoming really critical at the moment. I mean, every time you switch on your TV, there's a fire or flood. I think coming back to the materials as well, I mean, as was said previously, you know, 20 years ago, we were doing a lot of recycling. You know, we were doing recycling plastic for pontoon decks, concrete, steel. I think what's also interesting in our materials for the new buildings, also the specification, as design engineers, writing those specifications to include, I mean, you look at your top three costs: concrete, steel, and then pretty much, well, rebar, steel, and then also the glass is the most expensive and most carbon inefficient elements. But the materials nowadays, there's been a lot of research and development. I mean, one of the major fabricators here, concrete producers, was saying that they can produce concrete with 90% less carbon. That's a big number. You know, you look at some of these buildings, the concrete volumes are astronomical, because especially the high-rises, they use a lot of concrete because they're structural. Have a look at the hydrogen processes now that they use to actually produce steel. Again, if we can specify that, a lot less carbon, embodied carbon, and obviously the other question is, can we do it locally so that, you know, operational carbon and, you know, transporting it doesn't come from various distances. So again, there's a lot that we can do, but I think from the perspective, I think that's also why it's great to have COP here. I mean, where's AECOM are the sustainability consultants? And again, we're helping drive the decarbonization in uniforms using, you know, recycled bottles and stuff for the uniforms that you see here. So again, there's a lot that we can do in terms of technology, materials, but also the speed. And I think we can't sit back. We've got to do the old buildings and the new to actually achieve any of our targets.
The speed, indeed, super important, because if we were to build a building right now, we would look what's on the shelf. And yet our challenge is, what can we do? What do we have to do to maintain a chance to reach the one, or to not exceed the 1.5 degree centigrade? But even though we're in a building or we'll be later on in a vehicle, where everything starts and where everything is determined upon, it's actually on the drawing board in the factories. So where's the material sourced? How is it being transported to the factory? How efficiently is it being used? Like it's near Christmas, and everybody has, well, at least in those areas where we have Christmas, tried to bake cookies. And the more effectively you arrange the forms on the cookies, the more cookies you get. So it's material efficiency, energy efficiency, but it's also determining upon the lifetime energy requirements of whatever is being produced, the lifetime footprint of building technologies, i.e. heating systems, etc. So determining the scope 3, determining the durability, the repairability, and how well it can be recycled. We had dealings with people that do flooring, and already 3 years back they told me they have an 80% recycling rate, and I told them, wow, you're quite advanced in terms of sustainability. And he said, no, that actually wasn't the driver. It was more that it's getting increasingly difficult and expensive to get a hold of materials. So there's a strong business case also to design so that you can get it back. And the good way here in terms of transport is that, at least in Europe, there's a requirement for certain product categories and sizes to take the old stuff back. But hey, how good is that? If you sell new stuff, you get money, you get the raw materials for the new stuff out of the old stuff, and your truck is not even going back empty. Yeah, so that design for recycle is super crucial, and therefore acknowledging what we can do in the industrial sector means we have to start right now empowering those people who design products to take that on board, to have very, very quickly those products available on the shelf, but at the same time doing training and education for those people that plan the buildings so that they know about these things. And it's not only about new buildings, the tricky bit is the existing buildings. So how we can cleverly combine those existing buildings with existing technologies and the use within the buildings. Because the super great drawing board exercise may not work if you have buildings that, for instance, have very hot thermal processes, and you have building codes where you need to insulate that part of the building, which means you need to have heavy air conditioning to fight that overheating, etc., etc. So clever combination of everything.
Thank you. I was just going to pick a further point to what Craig said, but you've covered part of it as well. This is really refreshing for me, because I think for the first time the events like this in this year is that we're sat here as the built environment, and we've got the answer. This is not now how. This is not can we do it. This is how are we going to do it. And I think as a panel, as an industry, we now sit before society and say we can do this, right? We're not frightened by it anymore. We can do it. All the things. I mean, I think we've got to a place that we're designing buildings that are efficient in operational energy use. There's loads of those. There's lots of great examples of that. We can do that. I think so now we're moving on to looking at embodied carbon and how we can get more efficient, how we can squeeze that part of it, and how we operate. You touched on behavioural change. Well, I think there's a whole piece of work there to do, because half of the auditoriums we've been sat in today, it's 32 degrees outside, and we're calling them to 15 and 16. Surely we can go a little bit higher than that. But the point so we can do it. So why aren't we doing it? And it's back to you're basically, if your governments regulate for it, it becomes easy. Or if you've got a client that's going to do 30 cents, that's brilliant. But if not, it's how do you encourage people to do it? And then you come back to the cost, because there is an additional cost. How far are people going to go? I think the research we've been looking at is that people are very principled. Whilst it's probably 10%, 12%, get to 15%, get to 20%. And then it becomes a lot more difficult for them to justify. But I think on the whole, this is a good day for us.
I would just like to remind our in-person audience that Q&A will be approaching soon. So please feel free to think of any questions, and we'll be having a very engaging Q&A after. But we have started talking about the building regulations as well, and the policy changes required. So Christine, would you like to start on this, and perhaps if you had anything to comment on a previous point as well?
Yes, thank you. And I think, like you just said, regulation, I think, is a crucial part. I think regulation has a very big responsibility in order to give guidelines, in order to as well have something on the timeline where people can prepare for, because the last thing in the building sector we can do is react to trends left and right. I mean, this is what we see at the moment. Projects, they're completed now, and 3 years ago it was very in to have a smart building. They're being completed today, and everyone is like, it doesn't really, it doesn't really fit anymore. So it's a long-term thing, and I think this is a challenge for regulation. Where I'm always a bit concerned, because we're having the discussion in Europe and especially in Germany now for so many years, is as well, how can we finally get to a target-oriented regulation? How can we have a regulation in the building codes where it's about what's the CO2 budget in construction, what's the CO2 goal in operation? We know that in Europe it's 0, or it should be everywhere in the world, it should be 0. And we see too much prescribing in regulation, and we see too much, especially in Germany, hopefully in other countries it's different, a lot of ministries, and they somehow always just have a piece of the puzzle. They start to regulate and it doesn't fit with something else. Like a small example, my favorite topic, air conditioning and the comfort. In Germany we have guidelines for health of workers in their working environment. And in there you have requirements for basically air conditioning volume streams, and that even says in there, if you cannot guarantee for building materials who don't emit, toxins in a certain amount, you actually have to do more air ventilation. So that is a complete disaster in terms of sustainability. So I think that is the big challenge for us as well in Germany or in Europe, is how do all these things align, because it's like there's a lot of good intention out there, but it gets very descriptive on one side, and then sometimes it contradicts something else. And this is what I would like to see, is more like target-oriented, more data and fact-driven regulation. What we really would need is a monitoring obligation in Europe, because the truth is we all don't know the energy consumptions of the building. We talk about renovation rates. These are all theoretical numbers based on age of buildings, but we don't know how they really perform. And I think we would say it's mandatory to monitor and declare the honest energy consumption. That would change the whole game, because how are we going to learn? Which architect knows the energy consumption of the building they have designed? Normally you don't, because it's up to the client, and then they're out and they go to the next project. So I think I think regulation as well has to make their turnaround into a future-driven view, and we have to have the strength in Europe, maybe especially in Germany, to let go of things, which is very hard for us in Germany in terms of regulation, because we always add on. But I think we have to realize certain things work. They're kind of the standard, no one gets excited anymore. So maybe we could reduce that in regulation, and we could see how we can harmonize that better, so we don't contradict sustainability with, healthy workers. And I mean, everyone wants to do something good, but sometimes, you have to kind of take a step back and see what's really the impact. And we have to go from efficiency to effect. I think this is the key thing, what we have to see. And now he wants to say something. No.
On that question of regulation, tomorrow is a big day. Tomorrow there will be the so-called launch of the building breakthrough. There will be 30 countries that will commit that by 2030, near zero emission and resilient buildings will be the new norm. And countries from very different geographies, and will commit to work on those triggering points that will make it effective. Because yes, it's challenging, it's to align the whole value chain on standards, on what is good regulation, how do you include carbon accounting, how do you create capacity buildings, and. So I invite you all to go to the Al-Waha presidency room tomorrow at 12:30, where there will be this official launch. And again, I think it's a very important step. It will prepare a first forum on buildings and climate that will happen in Paris beginning of March, with somewhere between 80 to 100 ministers in charge of construction that will that will come together to really work on those triggering points. So also I invite you in advance for March 7 and March 8 in Paris to this global forum on buildings and climate.
I just want to follow up from what both Adrian and Christine said. I think, look, legislation is always tricky because different governments, different politicians, in and out, voters. But what's standard is the guidance. So look at PAS 2080. I mean, that's a sustainability code that we can use across all of our countries. As the Institution of Civil Engineers, your institution, it sets the ground rules for sustainable development. There's some great data in there, and that's a guidance document that can be used in any country. Again, look at PAS 2060, which comes to the carbon calculation. That's actually a document that was audited on this site for this event. So again, the guidance is out there, the knowledge is there, and it's just the implementation, which brings us to the standards. I mean, buildings lead BREEAM standard locally. They've got ST-DARMA, POL ratings in the Middle East. But also we're now looking at the infrastructure standard. What is the standard? What is the platinum and the gold and the silver for infrastructure? So Envision is also something that we're really driving and that our clients in Saudi are also driving. Those set standards, and to achieve them, you've actually got to follow the codes and achieve the decarbonization, use the right materials, and so forth. So I think it's very positive. We're on a path. We've got the guidance, we've got the standards, and now it's just getting there and implementing and making it work. Thanks a lot. I'll pass over to Stefan.
Thank you. Even one more thing to add, now since you said that. What you just mentioned reminded me very much of the situation or the issue of transaction costs. So there are many people that would really like to improve things, but yet there's an increasing amount of regulation and things that you have to keep in mind. 10, 15, 20 different rule sets from different areas also. And that felt, when I heard it, something like a super hardware-equipped phone with an operating system that doesn't allow you to use the phone. Yeah, so that means we need to find a way, and ideally, I spoke with somebody earlier today, but that was on manufacturing more, to equip those that build buildings with a coherent, integrated something where they just have one piece that combines everything and you go through that one piece, and then you can actually pursue that, rather than having to combine everything yourself. And that is not only you, that's all builders have to do that. That's such a waste of time unnecessarily, if that was feasible. The question is whether that's feasible, where we have local authorities with their own building regulations that are different in every single local authority. So standardization and aggregation is super important. And what you mentioned just called for the word of location efficiency that links to mobility. I only need mobility when what I need is not available where I am, only then. And therefore, thinking structurally is crucially important.
Just to add to what Craig mentioned, I think it's quite important that we all take a global perspective while designing the standards. Standards are good, it's a must-have, but there must be proper inclusions. When we are designing standards, we must not focus only on what's applicable in the developed nations. If we don't include the developing countries, we'll just be kicking the can. That's all we're going to do. And adaptability of these standards, setting very realistically achievable milestones and goals in these standards, and providing the guidance that can be adapted to different regions and continents. Those are key. So practically all I'm saying is while the standards are being designed, there must be a very, very detailed stakeholder engagement process from all participants around the globe. I know we have a very strong challenge of data. In the room, I've had various boxes where we've had engagements, and the same question, the same problem came up, data availability. Although we are not going to stop, we still have to move forward, but we must all try to push further to see how the inclusion process can be done so that everybody starts working towards the same goals at the same time, looking at the standards. They can actually achieve the same goals in different regions like every other person is pushing.
Thank you so much. So we talked about the best practice, about some guidance, about building regulations, but also one important challenge which I think we need to address is the skills. So, Adrian, as the president of a chartered institution, what kind of challenge do we have with the skills and how do we address it?
Well, yeah, we're well, possibly two, certainly threefold. But so we know we're going to need more people. We're going to need to upskill our existing workforces, and we're going to need more new entrants to the industry. In the UK, we're anticipating we need another 200,000 to 300,000 people in the construction industry, and I would imagine that would be the same all around the world. So we're going to need lots more people. In SIBSI, when I became president, we relaunched our STEM ambassador scheme to try and to get our members that established and the new entrants to put it just a little bit of time back in to get into the schools, colleges, and universities, so that we can and the primary schools, so that we can get people start thinking about engineering, so we can shape a future in engineering. It shouldn't be as hard as it has been, because we've now got computers, we've got climate-based modelling and stuff. So historically, when you go along to careers fairs, it's been very difficult for the built environment to compete. But we can now do, and for the youngsters, we can do computers, we can do that modelling, we can do 3D, we can design in 3D and then link it to prefabrication. So all of that suddenly ticks all their boxes. And on top of that, they're saving the planet, which is their inheritance. So that's the first thing, we've got to get more people in. We do need to, that then contributes to training them and training our existing staff. All of that is beholden on us and beholden on the PEI's, professional engineering institutions, to do that and to support those. We do that through ongoing CPD. SIBSI, as of January 24, is mandating all of its members to do 20 hours CPD, and 2 of those modules will be in net zero. So we're shifting the focus on that. And obviously one of the benefits, I suppose, of COVID was that we all have turned much more so to online webinars and both interactive, and so we've rediscovered our appetite for learning, which I think can only be a good thing. So I think there's lots of opportunities there. I think most people recognise it. Organisations are looking at their organisational capability and recognising it. So I think it's there, it's in place. It's another one. We just kind of need to get on with it.
Skills, huge topic. However, integrating those skills is a challenge that we have to get better at, because if you build a building, if you renovate a building, if you optimize a building, you traditionally, particularly when you pursue passive design, you have very different trades that need to learn how to interact, how to not ruin each other's work, and how to make the work actually work out. So while standardization on the overall design is good, checking whether it's properly installed needs to be on a building by building approach. And in respect of training up, it's super important that we share that information with people that look for different working opportunity, that look what they want to work in what trade, because as you say, we need millions of people who know how to put things together smartly and on the job. So dual apprenticeship is super important from my personal point of view, when you learn the theory and the practice at the same time, because only that approach guarantees that there's a continuous influx of current knowledge and also the experience on how to apply it into the trades and the businesses. And that doesn't stop once you're finished being an apprentice and are a journeyman or journeywoman. That is a lifelong thing, and I've heard that there's an institution of architects that requires their members to take a training, and if somebody doesn't want to take a training, they will have to leave that association. And that is a good way of going, not kicking people out, but doing all what is necessary to train people up, and also to have a shift change in culture, that this is also an advanced profession. It's not that you have to do science and research all the time. This is also super important, and also high professional skills required.
I think the training is very key. So looking at the continuing professional development, all of our professionals have to do that CPD, and that's very important. But also sustainability has now become integrated in the design. Whether you're a mechanical engineer, a civil engineer, or a marine engineer, you actually have to incorporate sustainability. It's not an add-on. There's not somebody that looks after sustainability. It's the engineer developing the design that's actually trained as a sustainability expert. That's also key. And that comes back to the universities that you said. I'm a judge on the emerging engineers, and it's great to see the students and the universities engaged, and they're actually excited. Look at this, we've incorporated rubber into our concrete, or we're reusing this waste and stuff. So again, that grassroots training is important. And finally, a fun fact, all the staff at this event in COP, 10,000 of them have been trained in sustainability. So that's a great fun fact as well.
Just maybe one, I think yes, but I think on the other side, construction buildings is always the balance between experience and, knowledge. And I think so our generation, unfortunately, is not out of the game. This is where we do a lot of training. I know they don't want to sometimes, but I think they have to. So I think knowledge is really key. But I think on the other side, I think we have to be honest. There's no simple question to a complex problem. And building is something complex. It's regional, it's local. And I think it really comes down as well to a certain kind of attitude, and maybe as well to say no if you can. And we have some of our members, I know they say no to certain kind of projects. We say no to certain projects they want to certify with us. We say no. So, because in the end, someone is advising someone. And I think we always have this blame game. The circle of blame is always endlessly big, and the client wanted it, but then the question is, why would the client want that if they're not a trained engineer or architect? So I think we as well have to talk about the attitude, because as far as I know, there's no law in the world that forbids us to do a better building that is required by required by code. But that means hard work. That means people are really dedicated and who really fight for the better solution. But I think the good thing is we can already build great buildings today. We see buildings in Germany, they're already climate positive in operations. They generate more energy than they use. But it's always the people behind. So I think, we need to get started, and I think we as well have to have the attitude to fight for it and not take no for an answer. And if the client wants to have something crazy, we have to try to convince him to do something else. I mean, I think we're all not in an age where we could say, well, we were young and we needed the money, So it's kind of, I think it's our responsibility to maybe sometimes say no, at least try to fight to do it better.
Okay. I think one of the issues we've not mentioned here would be what leads us to the Operation Carbon Emission Reduction. And the key aspect that deals with that is commissioning stage in construction projects. And when we're looking at commissioning stage in construction projects, we tend to think we have to just leave it to the engineer or to leave it to the contractor to hand us a couple of manuals. Then it comes back to bite us at the end of the day. We must all have to insist in incorporating the training of staff and incorporating the SLA that drives you at least for like a year or two if it's a complicated system. and making sure that you have well qualified, okay, let me not say 100, trainable staff. One thing is being qualified, another thing is being trainable. So making sure that there are trainable staff that you assign to follow through with those commissioning stages, and make sure that it's done all the way to the details. Because if it's not properly done, like you find some contractors, they're just in a hurry to go get their retention, and they get the PM to just sign off whatever without even considering anything. And the engineer wants to move over to the next project, the architect wants to move over to the next project. Maybe they've been there for like 4 years or 5 years, you don't know, based on construction time overrun. And they've way exceeded their post-contract fees. So they want to leave. They don't want to be there with you fighting the battles. So the commissioning stage is a very key aspect of project completion that we must all focus on when we're at that point. That's when we impact and transfer the knowledge to whoever it is that is going to run it, and also get them to deal with the defects that they had actually put up in the building during the construction. Yeah. But in terms of skills, I must say it's quite difficult to get good people. It's very difficult. So when you keep them, you try as much as possible to keep on training them and put up some good training budget to keep them always attuned with the new trends.
Can I just add one other point? I don't think it's just engineering training we need. I mean, you've just mentioned, post-contract evaluations and everything. It's also collaboration we need. It's leadership we need, because, you're talking inherently about the M&E, but we can't control that on our own. We need the ownership of the entire team to say we're not going to hand this building over until it's working properly for our client. Sorry.
So we'll get to Emmanuel, then very, very briefly from Stefan, and also I just want to hear calls to action at the end. So in your closing statements, if you could include one call to action for the industry, any stakeholder in particular, or the industry as a whole. Thank you.
No, I just want to conclude again on skills and attractiveness. What we are talking about is changing what is building and construction, and it can be highly attractive in a field where still building and construction is seen as I would say old and non-attractive side of the business.
Shall I integrate the call for action? Yeah, okay, good. I'll do that. Now, on the skill side, I'll mention something in a second. But what is a new component of what we need to consider is the digital tools, because that isn't something that is typically incorporated in the training, because it's yet another dimension, and it's super important for those people devising and designing the building also to be knowledgeable on the ins and outs of building information systems, on how to measure and utilize the data arising to improve not only the building design but also the building use. And when you mentioned that earlier, I thought, yeah, regarding meters, yes, we have smart meters increasingly, but what we should have is heat meters to see where we're wasting heating or ventilation. So there are lots of things that we can even improve on more. And enabling is super important, particularly in these times where we have hiking energy costs that take away the means of investing to reduce the energy consumption or to renovate the buildings, and finding ways for all types of building owners and builders to incorporate that, to be able to improve the buildings, whether they're existing or new build. But regarding standards or trying harder, it's like in school. And I know that from my own experience, learning for the passing grade can be quite stressful because you never know whether you actually made it or not. Whereas trying your best, seeing what can I achieve with my knowledge, with my time, that is such more positive, and I would like us all to have that in mind, to try what can we achieve. And then human psychology really does something fantastic. we get this craving for trying to be better, trying to beat ourselves. And I hope we put some of that spirit across to you all. I certainly have it. You can have more from me.
Yeah, I think just in closing, I think, you know, it's our responsibility, you know, to leave a sustainable legacy. And that's really why, you know, we have a unique opportunity. And I'm hoping that that's the reason that we're all at this event, you know, is to drive through action. And we've got the tools, we know we've got the innovation, we've got the willpower. Let's train people up. And, you know, I think that's the whole objective. You know, our built environment is important, and we need to leave a sustainable legacy. So that'll be my closing hope.
Yeah, maybe I can just repeat that a little bit. I think it's not rocket science, and I think we should stop overcomplicating things. It's a lot, I would say, common sense. And I think everyone always has to ask themselves. I always ask the question when I'm in a meeting. My question is then always, would you like to live or work there yourself? And, you know, if then the client is kind of not responding, I'm like, well, maybe then you should think about it again. So I think we really have to make building something personal. We have to get started. We have to be very pragmatic, and we can just make it better. And I think so we should not be always so afraid of change.
I think one thing that is clear to us all is we've identified that there's a need to take action. And it's more like a responsibility that lies on all of us. Both the private sector and the public sector, they need to come together, and the regulators will have to make reasonable policies that encourages the private sector participation, because they can't just do it themselves. They need that collaboration. So practically, it's going to be a systematic kind of approach. Both private and public sector, the government as well, needs to roll out favorable policies that will make all industry participants see reasons and benefits in actually employing these green initiatives, and we work towards the 2030 target, because 2030 target I honestly can't say if it's achievable because of the time frame ahead of us. It's quite short, but with technological advancements that we've seen within the recent years, I think it's something that might be possibly reasonably achievable with high dedication and commitment from all stakeholders. Thanks.
Thank you. My presidential theme is about leadership, and I'm going to stick with that. And we've heard this afternoon about how we've got the technology, we've got examples, and we're moving forward. We can now see a clear path ahead of us. All of us in our businesses as building and construction professionals can push on with that. So I think the call is for all of us to do that, to charge the way, to take our businesses, our clients, our new recruits with us. And I think the call on governments is for leadership also, to pick that up and to give us the regulation we need, because we can only take it so far in influencing our clients. And so I think it's responsibility for all of us, but let's crack on with it.
Maybe to close, reiterating my invitation for all of you to come tomorrow at 12:30 at the Al-Waha Presidential Room for the launch of the Building Breakthrough that will address a lot of points that we addressed during this panel.
Well, I want to thank all of our panelists today. I think we had a very insightful discussion. We've covered a broad range of topics, from changing the way we think to using more efficient materials, to addressing energy efficiency, to substituting materials, to building regulations and calls for action, both in terms of personal action of professionals, to governments, and to a broad range of stakeholders. So thank you so much. Thank you to our audience, and thank you for those who joined us online. Thank you.